So far, you've given us 4 scientific reasons why the Earth is really young. So we talked first about carbon dating. I asked you that one first. Second one, we talked about dinosaur bones.
Yes,
and then
soft tissue, DNA, things like that. Radiometric dating in general is number 3.
And then 4, we talked about the rock layers.
The rock layers being flat and bent.
Okay, give us something that's not quite so scientific.
All right, we get asked this question a lot. How can there be 8 billion people in the world if we started off with Adam and Eve? And that sounds impossible.
Yes, it does.
Until you apply the math. All you have to do is...
We constantly hear that the Earth is millions and billions of years old, but Dr. Robert Carter, you're a scientist. That's not what you say. You say the science actually tells us otherwise. And today, you're going to give us 5 scientific evidences that the Earth is actually young.
Okay, we can do that. Where would you like to start?
Well, I often hear about carbon dating.
Oh yes, carbon dating. Actually, one of my favorite topics. I wrote a long article on creation.com called How Carbon Dating Works. I'm actually involved in a carbon dating workshop. We meet twice a year. Some high-powered people who run carbon dating labs and archaeologists and physicists talking about this and how we can answer these questions from a biblical perspective. But really simply.
All right, so hang on just a second. You're sorry to interrupt you, but you say that they're biblical answers as
Absolutely.
opposed to what science says this.
Yes, but what I get to say now is, thank you, Mr. Evolutionist, for inventing carbon dating. That's ours. Go play with something else.
Go on.
That's how strong I am about this. But carbon dating specifically, not all the other radiometric dating techniques. They have different answers. But this one, we cannot find any carbon source in the world that has 0 carbon-14. That means they can't be millions of years old because carbon-14 breaks down really quickly.
How quickly?
The half-life is just over 5,000 years. So after 5,000 years, you have half as much as you did before. But there's not a lot of carbon-14. It's formed in the atmosphere very slowly from cosmic rays. And it's always just a little teeny bit. So as plants photosynthesize, they soak in the carbon. As we eat the plants, we soak up the carbon. It becomes part of our bodies. But if you bury something in the ground, it's cut off from any source of carbon-14. Right. It just decays. But we find carbon-14 in coal.
So, but if it was really old, it shouldn't. If it was millions of years old,
there should be 0. Now,
if it was even 500,000.
The theoretical maximum is about 70 or 80,000 years, and there'll be nothing left. We find it in coal. In fact, all different coals throughout the entire fossil record, from, they say, 30 million year old coals to 300 million year old coals, have the same amount of carbon-14. Oh, it's contamination, they say. Well, there are ways to get around contamination. Carbon dating labs know how to do that. We find carbon-14 in diamonds that they claim are 1 billion years old. You can't contaminate a diamond, it's a crystal. So where's carbon coming from? Carbon-14 coming from? We find carbon-14 in dinosaur bones consistently, about the same amount of carbon-14 in dinosaur bones. So we know these things are not millions of years old. Now, one of those forms of carbon might be, contamination, groundwater leaching of uranium or something, but not all of them. And consistently, all of them are giving us about the same answer as telling us the world is not millions of years old. That's a carbon-14 story.
Okay, so you mentioned the dinosaur bones. So yes. I've heard that there's actually been soft tissue found in dinosaur bones.
Yes, and that is a great second indicator of the youthfulness of the fossil record specifically. There's 2 types of soft tissue we might see. One might be like the petrification of something soft. There was even Charles Darwin, he wrote, I think in Origin of Species, no organism wholly soft can be preserved. So you would never expect to find a fossil jellyfish.
Right, which there have been.
Oh, we find tons of them. We find fossil raindrops, plants, insects, flowers. Lots of things are fossilized that shouldn't be, if, in Darwin's mind, slow and gradual. Something dies and sinks to the bottom, is very slowly buried. Well, then nothing soft is going to remain, only the hard parts. We find tons of remains of petrified soft parts. But then there's the other type of soft part, the non-petrified type. And that's the stuff that really should not be there. Starting off in about 10 or 15 years ago now, there's a large Tyrannosaurus rex they found in Montana, and they wanted to fly out the leg bone. They had hired a helicopter, but the helicopter couldn't pick up the leg bone. It was too heavy. So they cut it in half.
Ooh.
Yeah, world-class specimen. They cut it in half.
Ooh.
And then one of the scientists there, who's now very famous, sampled the inside of the bone, took it back to the lab, decalcified it using something I've used in a lab when I'm working on corals to get rid of the skeleton so I could study the tissue.
Okay.
She did that with the bones of the dinosaur and was left with soft, flexible tissue. And that wasn't a one-off. We've now found soft tissue in multiple dinosaur bones. We know now that there's reports going back at least to the 1960s where science is reporting similar things. Different places in the world, different types of dinosaurs, mosasaurs, pterosaurs, tyrannosaurs. Yeah, these things are not petrified. The soft parts haven't been replaced with rock. They're still flexible sometimes. They still stink. You can sometimes, some examples, you can squeeze the blood cells out of a blood vessel.
So there's still visible blood cells in there?
Yes. And bone cells and blood vessels and fibrous tissue from the skin that hasn't completely decayed yet. It's actually shocking. Now, there are ways maybe of helping preserve things over a long time. You know, you put your meat in the freezer, right? You don't leave it on the counter because it preserves it better. But even frozen, things like that don't last millions of years. And we've been studying this for over 100 years. The study of the breakdown of things over time is called taphonomy. This is a well-known part of science. We pretty much know how long it takes these things to break down. And this is shocking everyone, because even me, I think these things are buried during Noah's flood. That was 4,500 years ago.
So
That's
you
a
would
long
expect to
time.
find carbon.
No, I wouldn't expect to find anything. After 4,500 years, I expect it all to be decayed away. But if I'm incredulous, what's the evolutionist answer to this? I mean, I'm surprised. So maybe I was overestimating how fast things break down. Okay, fine. Twist my arm. They can last 4,500 years. But 70 million? That's a whole nother ball of wax. So we find soft tissue. We find blood vessels, skin. There's even evidence of DNA. And that's my field. I'm a geneticist. There should not be DNA. It should have broken down a long time ago. DNA is a really fragile molecule, much more fragile than the proteins in our skin.
Okay,
and
so
there's evidence of it being there.
Let me just ask you, maybe this is a sidebar question, but you, as you were talking about being a geneticist and there's DNA in there, so how far are we from Jurassic Park?
Great question. I would refer people to an article I wrote for Creation Magazine. It's now on creation.com. Mammoth clones coming to a zoo near you? With a question mark. And I was talking about the cloning of a woolly mammoth, that this lab is trying to do that. They're not going to be able to do it.
Why not?
Because the woolly mammoth genome that we sequence is in pieces. It's broken down. They can sequence the little pieces and compare it to elephants. We find out mammoths are more similar to an Asian elephant than an African elephant. That's really interesting. But they don't have a complete genome. The chromosomes are in little pieces.
They can't do it now, but that doesn't mean that they couldn't find more examples?
Manufacture it in a machine.
Ooh, how does that happen?
Well, they have DNA writing machines. You can write DNA, make DNA, but the problem is chromosomes are, tens and hundreds of millions of base pairs long. So we don't have the technology. But what they're going to do is they're going to try to genetically engineer an elephant and make it look like a woolly mammoth. Just like the reports this week. Now, by the time this video comes out, it'll be a couple of weeks, maybe a couple of months old. Reports this week of them resurrecting the dire wolf, an extinct species. But they didn't. They took a wolf and they genetically modified its genome to make it more like a dire wolf, with the big wolf that went extinct a long time ago. That's not the same thing as a Jurassic Park. That's not cloning a species. It's just modifying a species that already exists.
All right, so there's been information lost.
Absolutely.
They're not going to evolve. They can't clone this elephant to look like a woolly mammoth, and then it couldn't eventually evolve into a woolly mammoth.
No, they're gonna actually say that's the gene that makes it hairy. That's the gene that makes a big tusk. That's the gene that makes the head look a little funny. Change those letters in those genes, and try to get a female elephant to bear a mammoth baby. And boom, we got a woolly mammoth, but it's not really. So Jurassic Park is even worse because dinosaur DNA, it's there. We can see it with antibodies, and we can see it with DNA stains. But we're not able to sequence it yet because the DNA is broken in such tiny little pieces that you can't sequence it. Or if you did sequence it, you have 5 or 6 letters in a row. What does that even mean? You need a long piece of DNA before you know what it is. So that's the issue with a Jurassic Park-like scenario.
All right, Dr. Carter, you've given us a couple of scientific examples of why the Earth is actually young. We've talked about carbon dating. We've talked about the soft tissue and dinosaur bones.
Okay.
So give us a third.
How about radiometric dating in general?
Okay.
Now, most people look at that and say, oh, that proves the Earth is billions of years old. Not so fast. There's many different radiometric dating techniques. Each one of them, carbon dating being one, has a different answer, different assumptions, different applications. But when we do real-world testing of radiometric dating, it often fails. Like, for example, some enterprising creationists went to Mount St. Helens in Washington State. They exploded in 1980, so I was in 5th grade. And I remember it. I remember it quite clearly living in New York, the weird skies from the ash in the atmosphere. But they went and sampled the lava dome that formed after the eruption. So it was formed after 1980. And they used the potassium-argon method. It works like this. You have lava, there's argon, which is a gas,
right?
And there's potassium-40. So potassium-40 breaks down into argon-40. The assumption was while the rock is liquid, all the argon is going to boil off. And when it hardens, argon will be building up inside that, but only from the breakdown of potassium. And
so it should have had, according to their thinking,
zero.
Okay.
Yeah, it should have no argon. They sampled it at 10 million years old.
Really?
Based on the rate of breakdown of potassium-40 and how much was there, how much argon, looks like it's about 10 million or more years old. Same thing in Hawaii. I think the lava flow from 1950, several in New Zealand, 3 historical lava flows, one of the big volcanoes that have gone off since Europeans settled there. So we know those dates of lava flows, and they all date to millions of years.
So were these like blind tests that
Yeah. Send the sample to the laboratory and don't tell them where it came from necessarily. And here's it. The machine gives you a ratio. It measures how much of this and how much of that. That's good science. But the ratio is wrong if the thing is only a few to a couple hundred years old. Because the argon doesn't boil off out of the rocks. It's there. So we have to ask the question, how much argon is in rocks primordially? When we look at a rock that might have a lot of argon in it, how do we know that that wasn't in there when the rock formed? We can't know.
If you're enjoying this interview so far, you might be interested to know that we also produce the world's most widely read magazine on the creation-evolution controversy, Creation Magazine. It's packed with beautifully illustrated articles showing how real science supports the Bible. It's designed for the whole family and is a great tool for strengthening your faith. Subscribe now to receive 4 issues a year. Follow the link in the description. Okay, so you've got me thinking about back to middle school science and what we think about as science. It is observable, it is repeatable. So tell me, where's the breakdown in the science then if you're doing these tests and you're getting these invalid results? Or maybe that's not the right term for invalid.
No, you're thinking correctly. The science is sound, as in the machine, you put the sample in, it goes bing, and you're done, and you have a number. There's the number. We can test the accuracy of the machine. We can repeat the experiments. It gives us the same number. The machines are really good. It's the assumptions behind it that are wrong. The assumption that this thing is millions of years old, or the assumption all the argon comes out of potassium-40. We don't know that. It's an assumption. So when we ground truth it, the radiometric dating tests usually fail.
What do you mean by ground truthing?
We go to a place we know how old it is because we saw it happen.
Okay,
we sample it, and it fails. That happens a lot. And that's one of the Achilles heels of radiometric dating. So even radiometric dating does not prove the Earth's millions of years old, and a lot of tests show it's not.
So how would we ever know what is accurate and what is not?
We can assume that, like carbon dating specifically, those machines, the accelerated mass spectrometers, are down to such a level we can almost measure single atoms. It is unbelievable, but it's in a ratio of carbon-13 to carbon-14 to carbon-12. But it's so close we can almost measure single atoms. Those machines are amazing. They're precise. They're wonderful, beautiful, amazing things. But that does not tell us how old the sample is. It only tells us the ratio of the different forms of carbon in the sample. You have to assume a lot about its history in order to assess how old it is.
Okay, that's a lot to think about here.
A lot to think about,
A lot to think about. So if we're talking about having rocks tested That makes me think about just rocks in general, and particularly the Grand Canyon, where one can look, we see all these rock layers, and surely that's evidence of millions of years, right?
So that would bring us to point number 4, why the Earth cannot be millions of years old. Just look at Grand Canyon. Look at those layers, those beautiful flat layers laid down one upon another like a stack of pancakes. It's really funny, though, because most of the time in that wall of Grand Canyon is in the gaps between the layers, where the evolutionists are saying that these rocks were above the ocean, subject to the atmosphere and erosion, and then the ocean came back and laid down this shale or laid down this limestone. But there might be a 30 million year gap in there with no evidence of erosion, meaning there wasn't 30 million years, or there would have been canyons and all sorts of things in that flat layer that should have been eroded. So if most of the evidence of time is in the gaps, and the gaps show no evidence of time, the millions of years isn't true. A better solution is that these things were laid down during Noah's flood, one upon another, boom, 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 and actually the time is not there, just like the rocks tell us.
So were the rocks formed quickly?
Yes, the rocks are formed quickly, laid down quickly, one upon another during the flood year.
What might a quickly formed rock look like?
Well, it might look like a sandstone. Specifically, a lot of the sandstones in Grand Canyon, when you look at the angle at which there's these like cross bedding, they call it, these diagonal lines in the rocks, that's formed from water flowing over sand and piling it up, and it makes these mounds underwater. And the mounds stack up on top of each other at a certain angle. If that happens in air, the angle is steeper. In water, they're shallower, and all the indications of these sandstones that are laid down underwater.
So
Quickly.
They're not necessarily straight. They can be...
The sand piles up like that, but then it's cut off, and another thing is laid on top of it. It's cut off by the water changing direction, a new giant tidal wave coming through, or something like that. And now we have maybe a limestone being laid down. And limestone tends to have horizontal layers, not sandy sort of angular layers. All tons of things in the fossil record in geology showing us that things are young. I would really recommend people, if they're interested in that, dig in a little more. Just go to creation.com, type in sandstone, limestone, or type in bent layers.
Okay, tell us what those are.
If rocks are hard, which we'd expect them to get very hard over billions of years, you can't bend them. They'd snap. They'd fault. They'd break. Right. But we see massive areas of multi-stacked rocks with different layers, different colors, and they're bent like taffy. They're twisted. They can fold back on themselves. It's crazy, all the bending in the rocks.
How did that happen?
Well, they had to bend while they're still soft. And the only way for them to be soft when they bent is if they were laid down quickly and then bent before they hardened. So the flat layers that we see and the flat layers that have been bent and twisted around like they were still soft, those things are both telling us that the rock record is not millions of years old. Because if this rock is laid down millions of years before this rock and they're both bent together as if they were still soft, there's no millions of years.
Okay, speaking of the rocks, I want to talk about some really big rocks, and that would be the Rocky Mountains.
Yes.
Okay, so they are significantly taller and higher than the Appalachian Mountains.
Yes.
So how do you explain the disparity between the two?
Well, it's really kind of funny because in the evolutionary model, the Rockies, the Andes, the Alps, the Himalayas, other mountain chains in Southeast Asia are all geologically very young.
How do you
know that? The dinosaurs would never have seen those mountains.
What do you mean?
After the dinosaurs died out in the evolutionary model, millions of years later, these mountains started forming. They're actually very young mountains. They're sharp. Their peaks are very jagged still. They're not rounded down. These are late flood mountains. The mountains started coming up and helping to drain the flood waters off the continents.
All right, what do you mean by late flood?
Well, during the flood year,
it was a year.
It was a year. Noah was on the ark for a year, not 40 days, for a year. During that year, mountains formed. In fact, the Bible says mountains rose. Well, those rising of the mountains helped drain off the water. And once the mountain rises above the water, there's not much erosion left. You have rain and lightning and wind, freezing and thawing, but you don't have massive water swashing around, eroding the rocks down. These rocks are really young. Even the evolutionary model, they're really young. So we get to ask the question, how come the Earth started building mountains all of a sudden? All the major mountain chains in the world, except a few exceptions, are really young. The Appalachians being an exception. They're really rounded. They're really eroded. That was an early flood year mountain chain that rose up and got significantly eroded.
Because there was a significant amount of water.
Because there's still a significant amount of water on the Earth, yes.
So if the Appalachian are older, right, and the Rockies are younger. Then there's
we're talking 6 months.
That's a significant amount of water to erode.
Yes. And Noah's flood gives us that. Noah's flood gives us a recipe of rapid buildup of sediments and massive erosion of those sediments. The evolutionary model really doesn't do that. I think we have a better explanation of the rock record and the fossil record than the evolutionist does, given Noah's flood.
So far, you've given us 4 scientific categories, reasons why the Earth is really young. So we talked first about carbon dating. I asked you that one first.
Yes.
Second one, we talked about dinosaur bones.
Yes, and soft tissue, DNA, and things like that.
And we talked
Radiometric dating in general is number 3.
Right. And then 4, we talked about the rock layers.
The rock layers being flat and bent. Okay.
Okay. Give us something that's not quite so scientific.
All right. Let's do something really easy. Can you multiply by 2?
Yes, I can.
Okay, great. Let's multiply by 2 many times. We get asked this question a lot. How can there be 8 billion people in the world? If we started off with Adam and Eve.
Right.
I mean, 6,000 years ago, that's not a long time. It's even worse than that because 1,600 years after Adam and Eve, we had Noah's flood. And the whole earth was reduced to 8 people only.
So we've gone from 8 to 8 billion.
And we've gone from 6 to 8 billion because Noah and his wife don't count. Shem, Ham, and Japheth, their 3 wives, they're the founders of the modern human population. That was only 4,500 years ago.
So we've gotten from 6
people
to 8 plus billion.
And that sounds impossible.
Yes, it does.
Until you apply the math. All you have to do is double the population every 150 years, which is ridiculously slow. Human populations grow a lot faster than that. If at the flood there's 6 people, 150 years later there's 12.
And my guess is there were more than that.
I'm guessing a lot more than that, 150 years, yeah.
So this is kind of like compounding interest.
Exactly. In fact, it's the same exact mathematical formula as compounding interest, the formula for population growth.
Okay.
So from 6 to 12, say 300 years after the flood, there's 24 people. We're running out of time, aren't we?
Yes.
450 years, there's 48 people. How do we get to 8? Well, you just keep on doubling it every time, and you will arrive at something around the modern population in 4,500 years. Easily. We have to actually explain
how far back were we that it was 4 billion that we doubled?
Oh, I don't know, 1960s?
So relatively,
something like that.
So relatively recent.
Yeah, because it's an exponential growth rate. And so it just keeps on doubling and doubling and doubling. The only way to only have 8 billion people is we have to kill off a lot of people during this time.
To only have 8 billion?
There should be a lot more than 8 billion people.
Well, we've had some wars. We've had famines. We've had some
and
pandemics.
Disease. Yeah, those 3 things have kept the population way down. In fact, demographers have estimated that if there wasn't a World War I or World War II, there would be as many people in Europe as are in China.
Really?
Yeah.
Well, I mean...
Because of, wars slow down population growth.
Sure.
So it's really easy to get that number of people, starting with an Adam and Eve, starting with a Noah and his family. Really easy. We actually have to slow down the population growth to keep it low till we only have 8 billion people. Let's look at the evolutionary model.
Okay.
They say there's like a million early humans floating around the world for a couple of 100,000 years.
All right, so hang on. You said early humans.
Yes.
So
after humans evolve in Africa,
okay,
we start spreading out in Africa, like 300,000 years ago, we spread out maybe 30,000 years or so ago. But it's not
the evolutionary model.
The evolutionary model. So we have a population bottleneck where humans evolve, and then we start growing, and there's about 1 million-ish people. That's their estimate. It could be up or down. It doesn't matter. Give 1 million people with an average population generation time of about 30 years. because modern females can have children from about 15 to about 45, but not so much on the edges. The average is actually about 30 for the modern world. So assume that every 30 years, you have another 1 million dead bodies for 300,000 years.
That's a lot of
Where
dead
are all the
bodies.
dead bodies? Where are the graveyards? Where are the campgrounds? Where are all the stone flakes that people made? Where are the buildings that they built? Where's all the evidence of all of these people that have over hundreds of thousands of years? They're not there. Archaeology, we do find evidence of early people, yeah. Little, flint knappings in a pile, or a little village or something like that. But they're very few and far between, as if those billions of people never existed, because the earth is not nearly as old as the evolutionists want us to believe.
So you've given us several reasons. You've given us 5 good reasons
yes.
why the earth is really young, and there's science to back that up, right?
Yes.
And so you've mentioned creation.com, but we also have this resource, Evolution's Achilles Heels, this DVD. That
One of my favorites.
One of your favorites. Tell us a little bit about it.
Well, we identified multiple areas of science that are fatal flaws in evolutionary theory. That's what an Achilles heel is. It's a fatal flaw in something that looks like it's impervious to attack. And we identified them in all these different areas, and we got multiple CMI scientists. And for the documentary we made, we took people from the outside also. And so it was like nerdy kind of Christian creation scientist person. We asked them one question. They're all PhD scientists also. We said, okay, Mr. Scientist, tell us what evolution cannot answer in your area of expertise.
Okay.
And that's it. And man, they told us the most incredible things. We called them evolution's Achilles heels. And then we had non-scientists review this many times to make it understandable. And then we released it, and it's one of the best-selling things we've ever made. Very powerful. We've had so many comments and so many testimonials of people being encouraged through that.
And because this is such a great resource, we're going to make it available as a free stream.
Awesome.
Look in the description.
Okay.
Thank you so much, Dr. Carter, for being here and giving us some great reasons that the Earth really is young.
You're welcome.